Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And uh, how are you? I hope you all are doing alright and motivated to continue your lesson. So in this video, we're going to discuss on a topic, a part of chapter 3.2, where we have to analyze trust system. So we're going to analyze trust system. So what we want to analyze is to know the internal force and the condition is either the member is the trust members is in compression or in tension. So this is one question that I have right now. So you can see this is quite a simple trust system. This is the trust system, the typical trust system that you could have in your PSPM, I believe. It wouldn't be complicated. So at least we have like 5 to 6 joint here. So this joint A, B, C, D, and here I have 5 joints, but typically can go to 6 joints, but I don't think it will be more than that. But anyhow, so today we're going to look into the concept and how to solve this kind of question. So this question asks us, figure 1 shows roof truss system carrying loads based on the figure. Calculate the support reaction. So of course, as usual, the first step is to calculate support reaction, RAY and RBY, and here we have horizontal load 60 kN, meaning that at A we are going to have RAX value. And then number 2, calculate the internal forces for each truss member. So we have this all truss member AC, member AE, member CE, member CD, member DE, member BD, member BE. So all these members we have to calculate. We have to find out the value of the forces within. And the third is, of course, to determine the type of internal forces in each member, tensile or compressive. Alright. So basically tension or compression. Okay. Anyhow, so let's do the question. Alright. First of all, what we really need to do is to find out the support reaction first. So I would recommend you to draw the FBD first, but the FBD wouldn't be that much different. So what I'm going to do is I'm just going to put it on the diagram here. So we're going to have RAY here and RAX here. RAX here. And then RBY over here at B. Okay, so we're going to start with by using the concept of total resultant is equal total moment of resultant of bending moment is equal to 0. So we're going to assume at point A, assuming positive clockwise is positive and this is equal to 0. And then we're going to start, everything goes to here. So we just have 50 kN. So this is 5 because it's moving here. So it's going to be clockwise, so positive 50 times 50 times with the distance 6. And don't forget we also have this moment here, so remember, a line along the direction. So here we have the D value, which is 4. Okay, so therefore this one is going to this direction here. Then it will be counterclockwise. So it's going to be minus 60, and the D is times 4. And then our RBY, we don't have any other point load, any loading, so just gonna put here. So this is also minus, and this is 12 RBY. Okay, 12 RBY, and this is equal to 0. Therefore, from this equation we can get RBY, and you can check with your calculator. I got RBY is equal to 5 kilonewton. Okay, now since we have RBY, we can use force of equilibrium of force equal to 0, and then of course I'm going to look at Y first. Therefore, RAY plus RBY, which is 5. So this here is 5. We got from here. And this is equal to 50. Okay. Therefore, our RAY is going to be 50, which is from here. This one, 50. Therefore, we get RAY equal to 45 kilonewton. Right. And then don't forget, we also have another one, which is the horizontal load. So, we're going to use total Fx equal to 0. Therefore, RAX, we assume RAX going to this direction, to the right. And to the left is negative, which is minus 60. And this is equivalent to cos 0. Therefore, our RAX is 60 kilonewton. Okay, when we got positive answer, meaning that the direction that we are assuming, which is to the right, is correct. Which is, this is 60 kilonewton goes to here. So I'm just going to label this up. So this is 60. And this is going to be 45. Okay. So now we're done with our separation. The next step is to draw the explosion. I don't know, explode, right? Whatever you want to use. So we're just gonna redraw the joint. So this is joint A, joint C, joint D. Let's take here joint E. Okay, about here joint B. So, not really. I want to make everything on here. Alright, so we're just gonna label it back. A, C, D, B, and E here. Alright, so don't forget just to put the member and make sure you don't miss anything. So take your time and really I have to double check so many times in case. So many times double check everything. Okay, so the next thing that we're gonna do is to label up all the internal force. And remember, we assume everything is positive. So in thrust analysis, positive means, of course, means tension. But in terms of direction, we assume it is going outward. And of course, for compression, negative and going inward. So here what I mean. So we assume that any internal force member, so along this direction, is going outward. So this is our note here. This is our note here. Yeah. Ayah tengah buat kerja kejap kita Omar. Okay, so here we're just gonna have outward as well. So it must be in the direction of the member. Same goes here. So here. So here. So here. Yeah. Outward. 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 And then outward. And outward. And then the label here, so what you want to label here, the force here, we're just gonna label with AF A to C. So if we have FAC here, therefore this one also is FAC. It will have the same value and the same direction. So they're gonna use the same name. You can use FCA as well, but that's gonna make things complicated. So we want to make things simpler. So we just use FAC. So the same goes here. FAE. And notice that I use the earlier letter first as at the beginning of the name. So if we have member CD or member DC, we use a member CD. So this is FCD, and then the same FCD, right? So this is FCE, therefore we have FCE as well here. Alright, and then FBE, FBE, FDE, FDE, FBD, FBD. Alright, do we have anything else? So we have to double check. So we have 2 members here, alright, 3 members here. Now we have everything, 4 members, 3 members, 2 members, and so on. Alright, the next thing you want to really not forget is to also label up all the point load, the loading, the known load you already have calculated or given. So here 50 and we have 60 here. Right, so don't forget to put it back here. So we have 45 going outward, going inside here, going out. The force here going 60. It is 60. This is 50, and then this is 5. Right, now we have our explode diagram. Right. Alright, so next what we're gonna do is we would like to check to find out, before we begin anything, we want to know the angle here. So this angle, as you can see, it will be the same as this one as well. Alright. Why? Because it says here the distance is 3 here and 3 here, with the height of 4. With the height of 4. Okay? So 4, 3, and 3 here. Okay. So we're just going to check by using tangent theta is equal to 4 over 3. Therefore, we're going to get theta is equal to 53.13 degree. Okay. So now we have all the information that we need. Okay. Now we're going to start doing the analysis. So we're going to go zoom one by one. So I prefer to start with support, where we have our support is where we have 2 unknown only. So in this case we have 3 unknowns. This case we have 3 unknowns. This is 4 unknowns. So that will be quite difficult for us to solve. So we're going to start with the joint that only have 2 unknowns. So in this case we have A and B. Alright, so now I'm going to start with zooming to joint A. So just name our work here joint A. Alright, so we're going to zoom in on the joint A and start with drawing your XY axis. Alright, so from the diagram here we can have, just draw the same here. We have FAE, we have FAC, and that angle here theta, and then 60, and then 45 going upward. Alright, and that's it. Now we're gonna use equilibrium of particles. So you start with total Fy positive equal to 0. Therefore you're gonna have 45 plus, because FAC, the Y component going up, so 45 plus FA sine, gonna be sine 53.13, as our theta is 53.13, and this is equal to 0. Okay, therefore we're gonna get our FAC. FAC is equal to negative 56.25 kilonewton, and don't forget to mention this is in compression. Okay, I always suggest my student, don't use C, don't use compression, just put compression. Please complete sentence in compression. Right? Okay, then we have another equation, total fx equal to 0. Therefore, we're gonna have 60 to the right, 60 plus FAE, this one FFE, going to the right, and then also plus, okay, here notice that I'm just gonna use plus because the FAC right now, the x component is to the right. Okay, FAC, okay, of course it's gonna be cos theta, and this is equal to 0. So just gonna put it back. So we have 60 plus FAE. So just gonna replace. So FAC is negative 56.25 cos 53.13, and this is equal to 0. Okay, then if you solve this, therefore our FAE is equal to negative 26.25 kilonewton. Therefore, it is in compression. Right, so this is your answer for FAE and FAC. Right, so once we got this answer here, FAC, FAE, don't forget to label your explode back by giving the numbers. So this FAC is negative 56.25, and remember, FAC here is here this amount, this value. Therefore, the FAC also here is gonna be negative 56.25. Okay, the same goes to here, FAE. So FAE is negative 26.25, and over here also negative 26.25 class. So this step here is so important. Make sure you label it once you get the answer. Right, the next thing I'm gonna do is join B. So this one here, right, join B. So let's do join B. Oh. So for join B, just draw X and Y component, right? And then we have FBD. If you look at the diagram, this is FBD. The theta here, theta, and then FBE to the left, and then we have 5 from the support reaction here. Right, so this is your zooming for zooming in, this one, right? So now just solve it as usual by using total Fy, assuming going up is positive. Therefore, we're going to have 5 plus FBD sine, right? Because it's going up, so sine the Y component 53.13, and this is equal to 0. Therefore, your FBD will be equal to negative 6.25 kilonewton. And don't forget to mention this is in compression because we have negative here. Right. And then the next thing, we like to use the Fx component. So negative FB, so going to the left, so negative FBE minus, because the FBD here is going to the left, minus, so I'm just going to straight away make the substitution. So negative, here we know this is negative 6.25 from here, so just going to straight away minus negative 6.25, right? This is going to be quite confusing, so if you have confusion here, please pause this video and try to understand first. So this is negative 6.25. So if you want to make a reference, just refer to this, the same idea applied here. Okay, anyway, so negative 6.25 cos 53.13, and this is equal to 0. and you're gonna get FBE will be equal to 3.75 kilonewton, and this is positive, therefore this is in tension. So we're just gonna label back our value here. So FBD is gonna be negative 6.25. Right, so the one here as well, FBD here, and FBE in tension, so just gonna put 3.75, no positive, no negative, so it's just gonna be positive, and the same goes here, 3.75. Right, now if you notice, at point C, join D, and join E, now we only have two unknowns. So in the case of join C, we only need to find FCD and FCE, and the same goes for D. We have to find FCD and FD only two unknowns. And here, the same goes to here. We only have two unknowns, FCE, FD. So you can choose to start from where. So my preference is to start with C and D, and then for E here, we're going to use E to check if our answer is correct or not. Okay, I will show you later on. Alright, so then we're going to start with join C. So for our join C, we're going to have FCD, which is negative 67.5. Oh, sorry, this is the one that you're going to calculate later on. We're going to have FAC here, FAC, and FCE here. Oh, so just, and here is FCD, where we know FAC is negative 56.25 and FCE is 50. Alright, okay, now we're going to focus on join C right now. So join C. So just as usual, draw the X and Y axis first, and then we're gonna have our FCD here, and then from the diagram, from the explode diagram, we have FCE here, and the theta is here, and then here we're gonna have negative 56.25, and this is from FAC, and your theta is here. Okay, so we're gonna start with, we're gonna use total Fy going up, and this is equal to 0. Then just gonna solve it. So negative, negative, because this one is going downward, so negative, so this is going downward, and the value is negative 56.25. so just gonna put the value negative 56.25. okay, and this is gonna be sine y component 53.13 minus with, gonna go here big and then zoom out a little bit, 53.13 minus FCE component, y component, minus going downward, FCE minus because it's going downward, sine the same 53.13, and that's it, and this is equal to 0. Therefore we're gonna get our FCE is equal to 56.25 kilonewton, and mention this is in tension. Right, before we continue, the typical things that student gonna have trouble with is to understand the theta here. So one way of you to really understand here, okay, let's go back to here to our explode diagram. The only way, the way for you to understand theta and where is the theta goes on. So here, if you notice, this theta made up from these two lines here. Okay, right, line, which line? So horizontal line and the member. horizontal line, and the force here. Okay, so then we have a theta. Alright, so if you here you see here, we're gonna have horizontal axis here, horizontal axis, horizontal, and then this is FAC. So our theta will be this direction here. So this is gonna be our theta. So you really want to know what makes this theta here. Therefore, you just have to check. The same goes here. So this is our x-axis and this is our f here. So this is the theta, right? So it's gonna be the same theta. Okay. So please take time to really understand the angle. You have to really be careful with your angle. Okay. Now next we're gonna use total fx equal to 0. We're gonna have FCD to the right direction plus the x component 56.25. Alright, this one comes from where? So this one is already 56.25. We got from here. So this is from this one. 56.25 cos 53.13 and minus, because this is going to the left direction, minus and also minus because the value is minus. So you don't have to change anything, just give the value. So if the value is negative, just put down the negative 0.25 and cos 53.13 as well, and this is equal to 0. Therefore our FCD will be equal to, if you check with your calculator, negative 67.50 kilonewton, and therefore this is in compression. So ask yourself, what is the next thing we have to do? Yes, correct. You have to label up all this again at your explode. Okay. So here FCD is equal to negative 67.5, and this is negative 67.5 as well. And at FCE we have tension 56.25. Okay, 56.25, and here also gonna be 56.25. Now we're gonna do joint D. Now let's do joint D. So joint D. Oh, this is too far, I think. So as usual, draw your xy axis. So we have the value here, which is negative 67.5. Okay, this is coming from this FCD that we just found from here. Right, and then we have negative 60 to the left from the point load. We have FDE. Then we have here from the FBD, from joint B, we have calculated this here. So negative 6.25, right? And this is your theta, and this is your theta. Alright, now so we're just gonna straight away use total Fy equal to 0. Going outward is positive. So therefore negative FDE. Okay, notice here we only have one unknown left, so we just need one equation. So I'm just going to use Fy. Okay, so negative FDE sine, right? Negative because the y component going downward, downward, 53.13. Then minus, right? This is minus this one. So this is going downward. So this y component here going downward, and the value is negative 6.25. Okay, sine. Don't forget the angle. Oh, okay, never mind. So sine 53.13. And do we have any y component? No. So this one is equal to 0. So you're gonna get FDE equal to 6.25 kilonewton. This one is in tension. So now we have FDE 6.25. So just go back to our explode diagram here, and we're going to label it back here. So this is FDE here is 6.25 and FDE also 6.25. Okay. Alright, so students, if you see here from our diagram, now at our join E, we have FAE already, we have FBE already, we have FDE and FC. So here what I mean by, before I said we're going to use join E to check whether our answer correct or not. Do we have any mistake whatsoever? Okay. So what we're going to check, we're going to check if join E, and then we're going to check if total Fy and total Fx is really gonna be equal to 0. So of course we're gonna have y component here. So we really want to check whether we get 0 or not. If we get 0 or really close to 0 value, then our answer can be said as correct. We can be very confident with our answer. Alright class, so join E to check. So we're just gonna use join E. Put it a bit here. So join E. So just label back everything. So 6.25 here, 3.75 here, and then 56.25 here, then negative 26.25 here. And be really careful, don't forget the point load going downward 50. This is what normally students I think what I say carelessness here. They forgot to add on the point load. They are too focused on the force of members. They forgot to put in the point load. So we have point load at E. Remember? Alright, join E. Alright, so if you check your answer, if you done some questions and then you check your answer is wrong, try to check do you put the point load or not, because normally students always tend to forget to put the point load that is already from the question. Okay, so now we're just gonna check total Fy equal to 0, and we're assuming going up is positive. So we're just gonna do everything. So 56.25, so this one, so the y component is positive, so you're going upward. Sine 53.13 plus 6.25 here, 6.25 sine 53.13. And don't forget we have x component, y component, negative 50, and this is equal to 0, and you're gonna get your answer close to 0, and that is correct. So I have checked it, and you can check as well, and you're gonna get equal close to 0. So this is correct. Alright, and for join, so the next one, fx equal to 0. Okay, then we have negative, so this one negative because it goes to left, negative, and then put the value negative 626.25, and plus going to the right 3.75, right, and then we have minus this one, x component, negative, so minus 56.25 cos 53.13, and then just gonna make it down here, or just bring it to the left. And then also in this case, this 6.25 here, this one, plus 6.25 because going to the right direction, cos 53.13, and this is equal to 0, and we're gonna get very close to 0, and even exactly to 0, depends on your decimal place, and you will check the answer is correct. So we can prove that our answer can get right. If you don't get 0, like you got negative 5, too big, right? If too big, too much different, then you might have some problems somewhere in your calculation previously. Alright, so how much different normally is about plus minus 1. If it's plus minus 1, means like 0.8, 0.2, 0.18, 0.02, and that is, we can say, is close to 0. and your answer most probably gonna be correct. Okay, so before we end this video, don't forget, because the question asked to determine the type of internal force in each member. Okay, here you want to make another one, another what we could say, another additional answer. You have to list out all members. So mention we have AC, so all the members here, AC members, AE members, CD members, CE members, CD, so CD already here, member DE, member, and then BD, and then BE. So you have to count everything. Count your from the explode. You can check your how many members that you have. So to check, you really have list everything. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So we have 7 members. So here you want to mention just like this members. So mention again. So AC is in what? So AC is in compression. Alright. So basically you just gonna look at your calculation and just put down here like a summary. So AE we have also in compression. CD we have also in compression. CE is in tension. And then for DE is in tension. Okay. BD is in compression, and BE is in tension. This is the way that we're going to answer this question. Yeah, this is your final answer for truss analysis. And if you like, sir, should I put the value as well? This is much more recommendable. So if you want to put the number, so negative 56.25 kilonewton, much better. Right? But this is what we really want to know. Right? And then the answer is correct here. So I think class, that's all for this lesson. And I hope you understand the method. And if you have any question, and please leave in the comment section. And please, if you find this video helpful, beneficial to you, please don't forget to subscribe and like this video. Thank you very much.